When you send an letter, you are writing address, right? Like that, when you send a packet on that time, you are writing that source IP address, destination IP address, this kind of information. So this information containing field we are calling an IP header. So IP header will tell routers on the internet where to send this data packet. So you can include source IP address, that means address of the sending device, destination IP address, that means address of the receiving device. Then after time to leave mean you can write how many routers we need to pass until we reach the destination, right? By using this one we can prevent network loop. And also you can mention the protocol, whether it is TCP protocol, UDP protocol or ICMP protocol. You can mention this kind of thing. So this IP header is an essential thing to route in our network, right? So right, then we have IP header definition. It's a prefix to an IP packet that contains information about the IP version, length of the packet, source and destination IP address. So here you can see we have version, this kind of thing. Version means it could be IPv4, IPv6. Then after header length, type of service, total length of this packet, identification number. This number will be changed from one packet to another packet, right? By using this number we can identify our packet. Then at IP flags, that means do we need to fragment this or no need to fragment, this kind of thing we can mention here. Then at fragmentation offset means to identify fragmented packet we are using this fragmentation offset value. Time to live means how many routers we are going to pass. For example, when you send packet from one device to another device, you can mention time to live as a 3, for example. After that, so after reaching 3 routers, if this packet can't find its destination address on that time, so last router will ignore this packet and it will send a acknowledgement message to that sending router your packet has been discarded, right? So by using this kind of method we can prevent network loops. Then after we have protocol, TCP, UDP, ICMP, this kind of protocol. After that header checksum for the error checking. Then after source address mean our sending device address. Then after destination device address, right? So we'll discuss this thing one by one. So this is one example of the IPv4 header in our header information, right? You can see all the information which I told available here. IPv version 4. Then after we have header length, this is 20 byte header. So length is between 20 and 60. So this one is 20 byte because it is IPv4. So after that we have total length of this packet, this entire packet. Then after we have identification number, identify this packet. Then we have flags, right? So 1 mean don't fragment, 0 mean more fragment, right? So that means we don't want to fragment this one, right? So it is like 0, 1, 0. 0 is received, that means first one is received. Second 2 bit are first one for the don't fragment. If this one is 1, that means no need to fragment. The second one is more fragment. There will be more fragment coming with this one. After that fragmentation offset value, to identify the order we are using fragmentation offset value. Time to live 128 routers for this packet, right? It can go to 128 routers. After that protocol, TCP protocol. So header checksum for the error checking. Source address means our sending device address. Destination address means receiving device address. So as I told, we have this information. So you can check this information. We have version, header length, priority and type of service. Then after we have total length. Identification we are using differentiate the fragmented packet, right? So then after flags we have. So what is the meaning of fragmentation, right? So in the next video I will do the fragmentation with the example. For example thing, here we have one device, right? Then after we have our router. Then after we have another router. After that destination network router. Then after destination device. So you are sending a packet from here to here, right? On that time, think this is a 100 MB packet, but this link is 10 MB, right? then there's a maximum transmission unit this link can handle. So if that your packet size is greater than this limit, on that time you need to divide this packet, right? You have to divide this by that particular size. After that your packet will be divided, will send as a multiple small chunk. We are calling this fragment. After that, in the receiving end, it will again identify this fragment by using fragmentation offset value and identification number, and it will be the final data packet. Then it will show inside the destination device. So this process we are calling fragmentation. So in the next video I will do an example, practical example for this one. Right. So then after, as I told, we have time relief, protocol, header checksum, this kind of information. So option we aren't using nowadays, but we are using source IP address. That means our IP address, sending device IP address, destination IP address means receiving device IP address, right? So this is about IP header. So it is like a address from your postal card. Like for the postal card or letter, there should be an address field. Like that for the packet, there should be an IP header with this information.